In this video, I'm going to demonstrate how to factor by grouping. We generally use grouping when the a value in our quadratic is greater than 1. All right, so let's get started. So when you're factoring by grouping, it's very similar to what we do when a is equal 1, but it's a few more steps. So the first thing you do, grouping is also, let me say this, is called the AC method. You multiply the a value with the c value. So the first thing we're going to do is multiply 3 and negative 5. All right. So 3 times negative 5 is going to be negative 15. So usually this number in the back is what we say, okay, I need numbers that multiply to negative 5. Then when I combine them in addition or subtraction, I get negative 2. But that's not possible. So instead of using the negative 5, I use this new number, negative 15. So I'm saying, okay, what are some numbers that when I multiply them together, I get negative 15, and when I combine those numbers together, I get negative 2. Okay, so what about negative 5 and positive 3? And then negative 5 plus 3 gives me negative 2. So those are the two values that work. We're good to go. So that's the first step that's different. The next step is this. I'm going to take those numbers I got here. So I write down 3p squared. I'm going to insert these values into my expression. So negative 5p plus 3p minus 5. So these two here, they're basically where I broke down or expanded negative 2 to show that these two combine to give me negative 2. So now all you do, you're going to group them. You group them. When you group them, you're looking to factor out a GCF. So what do they have in common? So this first set, you have 3p squared minus 5p. Well, they have a p in common, so I can factor out a p. Then the last set, you have 3p and a minus 5. Well, the only thing they have in common is a 1, so I'm going to factor out a 1, a positive 1. Okay, in grouping, we want these sets of parentheses here to be the same. So that's good and that's good. So we know we're right. So our final answer, we put our outsides together in one set of parentheses. And we take just one of the grouped here, the 3p minus 5 and 3p minus 5. So my final answer is going to be p plus 1. And I'm going to take one of these, 3p minus 5. Let's go to the next one. Same deal. I'm going to multiply the first and last ones together. So 2 times negative 9 is a negative 18. So you're looking for numbers that multiply to negative 18, that when you combine them together, you get a positive 3. Okay, so those numbers are going to be 6 times negative 3, negative 18. 6 minus 3 is 3. So here we go. I'm going to have 2n squared plus 6n minus 3n minus 9, group, group. Okay. The GCF here, I got a 2 in common and an n, so I take out 2n. So that leaves me with n plus 3. Here, both of these are negative. Both of these are negative signs. So I'm just going to take out just a 3, I'm going to take out a negative 3, factor out a negative 3. So that's n plus 3. These are the same, great. So I end up with 2n minus 3 because those are what is on the outside. And on the inside I have n plus 3. Let's try another one. Same deal. Multiply the first and last one together. So that ends up being 12. So you're looking for numbers that when you multiply them to get 12, They combine and give you a -4. So let's see. Positive 12, that's 2 times 6. That's 12. But 2 plus 6 is 8. Okay, so 3 times 4 is 12. 3 plus 4 is 7. If I do the negatives, that's 12. -2 minus 6 is -8. All right, lastly, let's try -3 times -4 is 12. -3 minus 4 is -7. And then, of course, 12 and 1 is 12. 12 plus 1 is 13. And then the negatives of that. All right, so none of those work. When that happens, if none of the values work, guess what the answer is? The answer for this type will be a big not factorable. All right. Okay, let's go to the next one. Okay, so I'm jumping to number 6. Yes, I know I skipped numbers 4 and 5. I want to show you one like this. Remember, whenever we're factoring, the first thing we always look for is a GCF. Now, when you do grouping, you can wait until the end to do a GCF. I do not suggest it. Look at the beginning to see if you have a GCF like with any factoring. So this problem, I have a 9, a 66, and a 21. They have a GCF. Their GCF here is going to be 3. So I can factor out a 3. So I end up with 3k squared plus 22k plus 7. Okay. So now I follow the same process as what's left, but I'm still going to keep that GCF out there. So 3 times 7 is 21. So I'm looking for numbers that when I multiply them, I get 21. And when they combine together, I get 22. All right. So 21 times 1, right? It's 21. 21 plus 1 is 21. It's 22. So I end up with 3 parentheses 3k squared plus 21k plus 1k plus 7. Right? We're going to group. So this set of parentheses, we have a 3k in common. So I bring down that GCF. So in the first set of parentheses, I'm going to have a 3k factored out. So I have 3k, then I have k plus 7 left. In the second group, all they have is a 1 in common, so plus 1 times k plus 7. Close the parentheses, close those. So my final answer, I have that GCF from the beginning. My outsides, remember they go together still. 3k plus 1 times k plus 7. The last problem I'm just going to work through, number 7, and we'll see if you get the same answer I do. You can pause the video and see as you work. All right, so here we go. All right, that's the end of the video. The notes are attached to this video. Thanks.